Today on the Perception and Action podcast, a look at some of the most interesting research articles from 2021 so far. How do constraints shape skill acquisition? How can we interpret some of the classic problems in perception from an ecological point of view? What have we learned about the search for optimal movement solutions? So it's time for a call to action. Hello, and thanks for joining me. This is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception and Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. If you're a coach or an instructor, my goal is to help you bridge the gap between research and application, and to connect your experiential knowledge with skill acquisition and motor learning theory. I want to help take you from using practice design recipes to becoming a master chef who can manipulate the key ingredients to come up with your own innovative training methods. If you're a student or fellow academic working in the skill acquisition field, I hope to keep you up to date on the latest studies and help you get to know the people working in this area. Finally, if you're developing training technologies, I hope to help you incorporate good motor learning principles in your design, pull out key performance metrics from the data, and design effective studies to evaluate your product. To learn more, help support the podcast, and or work directly with me, please check out perceptionaction.com. Now on to the show. In today's episode, I want to talk about some of the articles that I've reviewed so far this year. For those that don't know, I have a YouTube channel where I post weekly videos in which I review a recent journal article. If you haven't been there before, there are a couple easy ways you can find it. A link to the channel is right on the front page of perceptionaction.com, and I've also posted a link to the playlist with all the articles I'm talking about today in the show notes for this episode. A couple points before I start. I'm not going to talk about all the articles I've reviewed this year, and not all of them were published in 2020. For this, I've tried to group articles into three themes that I've seen. The first are articles which have looked at the effects of different types of constraints manipulations on skill acquisition. I kicked off the year by looking at the often overlooked role of socio-cultural constraints in a really interesting paper by Uhara and colleagues. This paper investigates how the culture in Brazil has shaped the unique soccer playing style of players from that country. They discuss how the dexterity, flair, and deception shown by these players likely stem from the Brazilian malandro, a Robin Hood-type character that fought government oppression by being deceptive and cunning. This creates a form of life in Brazil where going against the traditional rules of play is revered. In terms of coaching, I think this article has some very important lessons in terms of the culture a coach creates around a team. For example, what is the relative importance of offensive versus defensive play? How are mistakes dealt with, etc. A few of the other papers I looked at manipulated task constraints through changing equipment. In an excellent follow-up to the study we discussed in episode 176, Tim Buzzard and colleagues looked in more detail at the effects of using scaled rackets and lower compression balls for youth tennis players. They found that the scaled equipment led to a complete change in the movement solution used, in particular more distal control with the racket further from the shoulder and more good variability in the stroke. Importantly, they also found that the scaled equipment provided better feedback and information for learning, in that there was a bigger difference between solid hits and mishits when using scaled equipment, which is of course what you want. The study I reviewed by Wen Yang and colleagues revealed results similar to this latter feedback finding, but in a very different context. In this, the authors compared the amount of vibration and EMG activity produced when a baseball batter hits a regulation ball off a tee as compared to hitting a weighted ball off a tee or a pitched ball. They found that the feedback created with the weighted ball was much closer to hitting a pitched ball, suggesting it might be more representative of real batting. The final study that looked at equipment constraints was one by Takara and colleagues. In this, the authors looked at the effects of adaptively changing the height and diameter of a basketball hoop on learning to shoot free throws. They found that training in a condition in which an algorithm adjusted the height and diameter based on your performance, for example, if you miss a couple in a row, it makes the hoop bigger, results in greater pre- to post-test improvement as compared to conditions where you just did half on the easiest settings, then half on the hardest, and a condition where participants were allowed to manually adjust height and diameter on their own. So overall, there's a growing body of research showing that appropriately manipulating task constraints via equipment changes can have multiple benefits, including more effective exploration of movement solutions, more representative feedback and better information for learning, and as a means to more effectively challenge a new learner at the optimal level. Another interesting constraint that was studied this year was pain. In a study by Area and colleagues, the authors looked at the effect of pain, produced by red pepper cream applied to the skin, on learning to throw darts. Although there were no effects of the pain conditions on performance, they did find that it resulted in a lower amount of movement variability as compared to a non-pain control group. I think it will be interesting for future studies to look at how pain serves as a potential constraint, in many cases a non-optimal one, on learning a skill. The final study I wanted to mention in this theme of constraints manipulations is a recent one by Maloney and colleagues that looked at instructional constraints. Specifically, they looked at how skilled swimmers adapt to different verbal instructions, emphasizing either an internal or external focus of attention on the dive start. Importantly, they found that the experts in their study were better able to adapt to the changing constraints in terms of maintaining overall performance outcomes. But how they self-organized their coordination solution, for example, in terms of the timing of peak forces, differed as the instructional constraints were changed. The second theme that seemed to emerge from the studies I've reviewed so far this year is what you might call addressing classic problems or effects in perceptual motor control from an ecological viewpoint. One example can be seen in the study of implicit learning training by Lola and Tzetzes. In this paper, the authors essentially replicated the findings from the work of Rich Masters and colleagues, which have shown that learning a task implicitly makes one more resilient to the effects of pressure. Specifically, in this study, participants were asked to practice volleyball serving while performing a distracting secondary task, which prevents explicit hypothesis testing. This resulted in more accurate decisions in a video-based lab test and serving more accurately under pressure on the court as compared to a control group or a group that learned through explicit prescriptive instruction. In my review, I questioned whether this type of implicit learning, where you distract a person from the environment, really fits with an ecological approach to skill acquisition. In my view, it doesn't, and I personally think it's time we sever the direct links many people are drawing between these two bodies of research. Another classic effect in motor learning that I looked at was interference. Egger and colleagues examined the interference that occurs from practicing different leg muscle stability tasks, one right after the other. The main task was balancing on a rocker board, while the tasks participants practiced right after were either highly similar, balancing on a wobbly board, or involved the same muscles with a different goal. For example, producing target forces with leg muscles rather than controlling the center of gravity. The classic interference effect was found, where practicing a similar but slightly different balance task impaired retention performance. In the video review, I discuss how we can interpret this very common result in terms of calibration of information movement control laws. The final paper I reviewed under this theme was the amazing article Perception as an Ecologically Well-Posed Problem by Bill Warren. This paper provides a fantastic basic review of the concepts of direct perception and affordances. It shows how Gibson completely reframed the problem of perception from trying to recreate the outside world in an internal representation to trying to pick up action-relevant information. The final theme I've seen emerging in the papers I've reviewed so far this year is how to find an optimal solution when learning a skill. I looked at papers that have tackled this from a couple different angles. In a really fascinating paper, Felton and colleagues show how biomechanical modeling can be used to identify small technical changes that could improve performance for a particular performer. In this case, changes to bowling delivery in cricket to increase ball velocity. This effort is leaps and bounds ahead of a previous work, in my opinion, which is focused mostly on identifying and correcting towards ideal techniques rather than self-optimization. However, as I also discuss in the review, there are still some major challenges to overcome. In particular, determining if and how this new pattern of coordination we've identified through modeling can be added on top of the intrinsic dynamics of a given performer. The final paper I wanted to mention was one by Pacheco and Newell. In this, the authors look at how the presence of local minimum, that is, movement solutions that are good enough but not the best, affect the search for the optimal solution, and how this relates to the degree of inherent variability in the performer. The overall finding adds to the author's previous work on this topic, showing that the path to optimality is not a simple story. Not all performers seem to perceive the layout of the task space, for example, where the minimum are, in the same way, and there's no simple relationship between how variable you are in your exploration and how quickly you reach the optimum. So that's some of the papers I've looked at so far this year. As I mentioned, I'm going to keep doing this weekly on my YouTube channel, so if you haven't checked that out, please do. Also, any suggestions for papers to review are more than welcome. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at Shakeywaits. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.